Hello guys, welcome back again to my YouTube channel. In this video, I'm going to share about the form to chart. There is strong connection within the flow, space, and activity relationship. The flow of the process may determine the locations of department. The flow of the process is obtained by the activity relationship. To find the best layout, there are so many ways to reach it. By changing one department layout may result significant things. In some cases, machine, department, and many more tangible facilities are represented by the cells, and the cell itself determines the space requirement. To determine the best layout, you have to select the initial layout as the base for exchanging the department. In logistics system, there are so many stages of material flow. Start by customer point of view, the flow from manufacturing facility, the flow within manufacturing facility, and the flow into manufacturing facility should be simple as it can be, thus may result lower production. And within the overall flow environment, a critical consideration is the pattern of flow. The flow within workstation should investigate the motion studies and ergonomic considerations, and it should follow simultaneous principle, coordinated, symmetrical, natural, rhythmical, and habitual principles. The flow within department is dependent on the type of department, product or process department, and the flow between departments used to evaluate the overall flow within facility. In product department flow, which the layout obtained by product process or family department. The flow pattern within department can be arranged by the position of the operators. They can be end-to-end formations, back-to-back, front-to-front formations. The pattern may have circular or odd angle shape. However, in the process department flow, there is a little flow between the workstations. The flow occurs between the workstations and the aisle. The flow pattern within department with material handling consideration usually adopt line flow pattern, but not limited to a line flow, U flow, W flow, S flow, or O flow. This is straight line layout. This layout is very simple and requires short production process. Within this pattern, the shortest distance between 2 points can be obtained, and the total material movement relatively is very small. Serpentine or E-shape or zigzag shape is work well for long production process, and it can help overcome space limitations, shape, and size of buildings. U-shape, this pattern can be used if the end point and start point of the production process need to be placed on the same locations, and it may help better transportation and monitoring of material in and out. Circular or O-flow, this pattern can be used if the end point and start point of the production process need to be placed on the same locations, and it has the similar definition with U-shape, better monitoring of material. Odd angle or W flow, this pattern generally used in these conditions. Space limitation that not allow other pattern to be applied. Fixed flow pattern needed. Somehow the machine will be installed very fixed and is very hard to be moved. So this typical case is better to use the odd angle layout, and it will give short route that can be very helpful for limited space. Flow within department with material handling consideration, there are so many patterns just like spine flow pattern, loop flow pattern, inner loop, tree flow pattern, and outer loop. In flow within the facility, the entrance and the exit may have big consideration. You can choose the same entrance and location point, adjacent side, on the same side, or on the opposite side. For flow pattern between departments, you can choose loop, structure, spine structure, segmented, or tandem. The effective flow within a facility depends on the effective flow between departments. Such flow depends on effective flow within departments, which depends on effective flow within work. There are signs of a good general flow pattern. A flow starts at receiving and terminates at shipping. Straight and short line of flow. Minimum backtracking. Material is moved directly to point of use. Minimum work in process. Flow pattern is easily expandable. New process can easily be merged in. The best effective flow is uninterrupted, no backtracking or colliding each other. As you can see in this picture, the first example is the good effective flow, and the upper side is bad flow. Backtracking increases the length of the flow path. Just take a look at the practice in here. Flow from A, B, C, D is the total calculations between 15 at 50, at 50, 75, and 25. So for calculating the backtracking step, the original distance may be counted, for example, in the practice below. A, B, C, D is a normal step, but if A, B, and back to the original one, which is A, you should count it the backtracking, which is the original step. So, it may have a double score. A, B, A again, so you have to step back and the score will be counted. And the same way for traveling A to C. A to C and D. The principle of effective flow, you have to minimize the flow. Make sure you deliver the material, information, or people directly to the point of ultimate use. Plan for flow between two consecutive points of use to take place in a few moments as possible. Combine flow and operations. And then maximize the directed flow path. Minimize the cost of the flow by using minimizing manual handling, whether use automatic or mechanize the flow, and minimize the trip of empty carriers. To measure the flow in real one is very complicated. To help this issue, there are many methods to calculate the process flow, both quantitative method or qualitative method. For example, in FTC, this is the example of quantitative method. In form-to chart or FTC, it requires large volume of material, information, and a number of people moving between departments. In terms of amount moved or distance traveled. For qualitative method, you can use activity relationship chart. And the characteristic of this method is very little actual movement of material, information, and people flowing between departments. Significant communication and organizational interrelationship between departments in terms of the level of relationship between unit department in the organization. And usually, in fact, we use both of them to create a facility plan. Form-to chart or FTC is a called travel frequency chart or trip chart. FTC is used for plan layout planning and material transfer in the production process. The FTC is used as a basic foundation for creating the initial layout. Making FTC requires other documents such as assembly chart, operational process chart, bill of material, and etc. FTC is useful for conditions where many items flow through an area, such as job shop, machinery shop, offices, and so on. The number on the FTC shows the total weight of the load to be moved, and the distance of material transfer, volume, or combination of this factor.